Topic 12: Protection Mechanisms. Part 2: Managing Network Security with Firewalls. In information security, a firewall is any device that prevents a specific type of information from moving between the outside world, known as the untrusted network, in other words, the internet, and the inside world, known as the trusted network. The firewall may be a separate computer system, a service running on an existing router or server, or a separate network containing a number of supporting devices. While most firewalls are an amalgamation of various options, services, and capabilities, most are associated with one of the basic categories or types of firewall. The most common types of firewall are packet filtering firewalls, application layer proxy firewalls, stateful packet inspection firewalls, and unified threat management devices. Packet filtering firewalls are simple networking devices that filter packets by examining every incoming and outgoing packet header. They can selectively filter packets based on values in the packet header, accepting or rejecting packets as needed. These devices can be configured to filter based on an IP address, type of packet, port request, and/or other elements present in the packet. This slide shows an example of 6 rules in a packet filtering rule set. The first rule: anything coming from address 10.10. whatever, aimed at any destination address and service port, is denied access. On the other hand, anything coming from any source address aimed at 10.10.10.24 for the SMTP service port is allowed. This presumably allows access to an electronic mail server. In the strictest sense, an application layer firewall, or application level firewall, works like a packet filtering firewall, but at the application layer of the 7-level ISO networking model. A proxy server works as an intermediary between the requester of information and the server that provides it, adding a layer of separation and thus security. If such a server stores the most recently accessed information in its internal cache to provide content to others accessing the same information, it may also be called a cache server. Many consider a cache server to be a form of firewall, but it really doesn't filter. It only intercepts and provides requested content by obtaining it from the internal service provider or cache. A proxy firewall, on the other hand, provides both proxy and firewall services. When the firewall, rather than an internal server, is exposed to the outside world from within a network segment, is considered deployed within a demilitarized zone, or DMZ. Using this model, additional filtering devices are placed between the proxy server and internal systems, thereby restricting access to internal systems to the proxy server alone. Stateful packet inspection firewalls keep track of each network connection established between internal and external systems using a state table. State tables track the state and context of each packet exchanged by recording which station sent which packet and when. A stateful packet inspection firewall can restrict incoming packets by allowing access only to packets that constitute responses to requests from internal hosts. If the SPI firewall receives an incoming packet that it cannot match in its state table, then it defaults to performing traditional packet filtering against its rule base, and if the packet is allowed and becomes a conversation, the SPI firewall updates its state table with the information. Whereas static packet filtering firewalls are only able to interpret traffic based on manually configured rule sets, dynamic packet filtering firewalls are able to react to network traffic, adjusting their rule-based content and sequence accordingly. They do so by understanding how the protocol functions and by opening and closing holes or doors in the firewall based on the information contained in the packet header, which allows specifically screened packets to bypass the normal packet filtering rule sets. Both SPI firewalls and application-level proxy firewalls are considered examples of dynamic packet filtering firewalls. Unified threat management devices are categorized by their ability to perform the work of an SPI firewall, network intrusion detection and prevention system, content filter, and spam filter, as well as a malware scanner and filter. With the proper configuration, these devices are even able to drill down into the protocol layers and examine application-specific data, encrypted, compressed, and/or encoded data, commonly referred to as deep packet inspection. Similar to UTM devices, next-generation firewalls combine traditional firewall functions with other network security functions such as deep packet inspection, IDPSs, and the ability to decrypt encrypted traffic. The functions are so similar to those of UTM devices that the difference may lie only in the vendor's description. According to Kevin Beaver of Principal Logic, the difference may only be one of scope. UTM systems do a good job at a lot of things, while next-generation firewalls do an excellent job at just a handful of things. Each of the firewall generations can be implemented in a number of architectural configurations. 4 architectural implementations of firewalls are especially common. These are the single bastion host architecture, dual-homed host firewalls, screened host firewalls, and screened subnet firewalls. Most organizations with an internet connection use some form of device between their internal networks and the external service provider. In the single bastion host architecture, a single device is configured to filter packets, serves as the sole security point between the two networks, and unfortunately represents a rich target for external attacks. The bastion host is usually implemented as a dual-homed host, as it contains 2 network interfaces, one connected to the external network and one connected to the internal network. A technology known as Network Address Translation, or NAT, is often implemented with single bastion host architecture. NAT is a method of converting multiple real routable external IP addresses to special ranges of internal IP addresses, usually on a one-to-one basis. That is, one external valid address directly maps to one assigned internal address. A related approach, called port address translation, converts a single real valid external IP address to special ranges of internal IP addresses. That is, a one-to-many approach in which one address is mapped dynamically to a range of internal addresses by adding a unique port number when traffic leaves the private network and is placed on the public network. NAT and PAT use special non-routable addresses that consist of 3 different ranges. Organizations that need very large numbers of local addresses can use the 10.x.x.x range, which has more than 16.5 million usable addresses. Organizations that need a moderate number of addresses, such as most home users, can use the 192.168.x.x range, which has more than 65,500 addresses. Organizations with smaller needs can use the 172.16.0.0 through 172.16.15.0 range, which has approximately 4,000 usable addresses. Screened host firewall systems combine the packet filtering router with a separated, dedicated firewall, such as an application proxy server or proxy firewall. This approach allows the router to screen packets to minimize the network traffic and load on the internal proxy, while the proxy examines an application layer protocol, such as HTTP, and performs the proxy services. The screened subnet architecture consists of a special network segment with one or more internal hosts located behind a packet filtering router. Each host performs a role in protecting the trusted network. Functionally, the difference between the screened host architecture and the screened subnet architecture is the addition of packet filtering behind the bastion host or hosts, which provides more security and restricts access to internal hosts only to traffic approved in the interior firewall device's rule set. The first general model uses two filtering routers with one or more dual-home bastion hosts between them. The second general model shows connections are routed as follows. Connections from the outside or untrusted network are routed through an external filtering router. Connections from the outside or untrusted network are routed into and then out of a routing firewall to the separate network segment known as the DMZ. Connections into the trusted internal network are allowed only from the DMZ bastion host servers. When evaluating a firewall, ask the following questions. What type of firewall technology offers the right balance between protection and cost for the needs of the organization? What features are included in the base price? What features are available at extra cost, and are all cost factors known? How easy is it to set up and configure the firewall? How accessible are the staff technicians who can competently configure the firewall? And can the candidate firewall adapt to the growing network in the target organization? Another type of tool that effectively protects the organization's systems from misuse and unintentional denial of service conditions across networks is the content filter. Although technically not a firewall, a content filter, sometimes called an internet filter, allows administrators to restrict content that comes into a network. The most common application of a content filter is the restriction of access to websites with material that is not business related. Content filters ensure that employees are not using network resources inappropriately. Any firewall device, whether packet filtering router, bastion host, or other firewall implementation, must have its own configuration rules that regulate its actions. A policy regarding the use of a firewall should be articulated before it is made operable. In practice, configuring firewall rule sets can be something of a nightmare. Each firewall rule must be carefully crafted, placed into the list in the proper sequence, debugged, and tested. Firewalls are limited by the constraints of their programming and rule sets in the following ways. First, they are not creative and cannot make sense of human actions outside the range of their program responses. Second, they deal strictly with defined patterns of measured observation. These patterns are known to possible attackers and can be used to their benefit in an attack. Third, firewalls are computers themselves and are thus prone to programming errors, flaws in rule sets, and inherent vulnerabilities. Fourth, firewalls are designed to function within limits of hardware capacity and thus can only respond to patterns of events that happen in an expected and reasonably simultaneous sequence. And then fifth, Firewalls are designed, implemented, configured, and operated by people and are subject to the expected series of mistakes from human error. There are also a number of administrative challenges to the operation of firewalls. First is training. Most managers think of firewall as just another device more or less similar to the computers already humming in the rack. Second is uniqueness. Each brand of firewall is different, and the new e-commerce project just brought you a new firewall running on a different operating system. Third is responsibility. Since you are the firewall guy, suddenly everyone assumes that anything to do with computer security is your responsibility. Fourth is administration. Being a firewall administrator for a medium or large organization should be a full-time job. However, that is hardly ever the case. Some of the best practices for firewall use are: all traffic from the trusted network is allowed out. The firewall device is never accessible directly from the public network. SMTP data is allowed to pass through the firewall, but should be routed to a well-configured SMTP gateway, in other words, a proxy server. All ICMP data should be denied. This means pings. Telnet terminal emulation access to all internal servers from the public network should be blocked. And when web services are offered outside the firewall, HTTP traffic should be handled by some form of proxy access or DMZ architecture.